welcome everyone to another interesting COVID semester, but it is really nice to see you all. See we're we're all in different places, and I'm looking forward to getting us back in the classroom soon. So let me just say that we've got this January 31st. Classes are going to kind of resume back in person, and I think by all indications, that is not just a random date that they're throwing out, but that's their intention. So I don't expect us to be remote after the first 4 classes, but who knows? So yeah, we should prepare for anything. But I think we're all pretty experienced at this point with remote learning. So hopefully, I don't think it should disrupt us too much. And it actually might be convenient because the first couple of classes, hey, Julie's cat, will be working with R. So it will be useful for you to be able to have a computer open and R open anyway. So this might be a good, good opportunity anyway. Okay, so I think just to get started, we'll kind of just go through the how the course is going to go, what kind of assignments you're going to have, what the schedule is, what sort of stuff you need, what the expectations are, give you a chance to ask any questions that you might have about the structure of the class, and then we can get started with the material. But let me just take some attendance before we get started. And that's great. So we've got 22 students in the class. And just so you all know, this is a slash listed course. So it's 4387, 5387. So we've got some students enrolled in the undergrad part, some students enrolled in the grad part. We're all going to work through the same content. The policies are going to be the same for everybody. The main difference is on some assignments, there'll be some extra work that the grad students will have to do that the undergrads won't have to do. And some of the time, that extra work will be open for undergrads to do for bonus or something like that. And let me also say, while I'm thinking of it, that I'm recording this. So if anybody has any concerns about that, feel free to just chat me or speak up if that's an issue. But otherwise, I will record this and post it up online so you can kind of catch anything that you might not have if you missed anything during today's class. Okay, so yeah, so we got 22 students in all. I think I know a lot of you, so that helps you and I if we know each other. But I'm looking forward to meeting all of you. So if I mispronounce your name or you have a nickname, please just let me know. Let me turn this off so we can see each other. So you don't need to see that. Okay. So Max, I see you're here.
Hey, I'm here.
Hey, Max.
Yeah.
Welcome. Julie, I think I saw you here. I saw your cat. Yep. Hey, Julie. Zoe. Hey, Zoe. Rachel Burke. Rachel, you not here? Okay. Let me know if I miss you. Kaden, I think I saw you someplace. Yep. Hey, Kaden. David, I saw as well. Hey, David. Nice to meet you. Derek is here. And Jordan. Hey, Jordan. Patrick, I saw you. Hey, Patrick. Samantha, I see you are here. Hannah. Hey, Hannah. Walker. Hey, Walker. Heidi. Hey, Heidi. And Kristen. I think that's the K. I think you might be here, Kristen.
Hi.
Yeah.
Oh, sorry. No, there's a Kristen and a Kirsten.
There's a Kristen and a Kirsten, yes. So I think Kristen is the big purple K from what I can see.
Yeah.
So, and while I'm at it, I've got you here as well, Kirsten. Thanks. Ryan, I see you here. Hey, Ryan. Vasi, I think I saw as well. Hey, Vasi. Kevin Rodriguez, got you here. Marcel,
Yes, I'm here.
Yeah, that was Kevin, right?
That was Marcel.
Oh, Marcel. Oh, there you are. Hey, it's hard. There's a lot of faces to try and pick from here. It's helpful when it highlights it in green. Let's see. Lindsay. Hello, Lindsay. Kaylee. Howdy, Kaylee. And Kirsten. Okay. And was there anybody else that I didn't call? Right. Well, welcome everyone. So for those that don't know me, my name's Adam Spiegler, and I just prefer that you call me Adam. If you don't feel comfortable with that, then the other option is like Dr. Spiegler. That sounds boring. So please just call me Adam. I'm totally comfortable with that, and that's what I prefer. And yeah, so some of you may know me from kind of various emails about advising and directing the undergrad program. So I kind of do double duty with that. So if you do have any questions about any of our undergrad programs, I'm also a good contact for that, or any advising sort of stuff as well. Yeah, and so let me kind of go over into our Canvas site and just make sure everybody is clear with that. And yes, I am getting back up to my multitasking here with looking at the chat and looking at all of you and then looking at my screen. Okay, so hopefully you've had a chance to go over some of this stuff on our site, but mainly everything that I organize, I try and organize things in the modules. So for people that have had me before, we'll kind of organize things in a similar way each week. So here's the materials for this week down in week 1. And if you have any sort of questions about RStudio, R Markdown, any of that stuff, there's also some materials here to help with that. So today and on Thursday, we'll be working with this R Markdown file over here that just says R Markdown notes. So I would kind of encourage you to download the Markdown file and open it up in RStudio if you've got that already installed. If you haven't installed R in RStudio, then you can work with the PDF version of this text, which is down below. And our first homework assignment is also posted in the form of a Markdown, our Markdown file. So you can take a look at that. And that is that won't be due until after we're back in person. So when we get going, we'll be working with these notes. I've got a couple of slides that I just want to go through first, just about like the course, the overview of the course and so on. But any questions about Canvas, how things are going to be structured in Canvas? Anybody having trouble finding anything in Canvas? Okay. I think I've got I've overdone it with my monitors. I'm now having trouble finding where stuff is. Okay, so let me go through some of those slides that are just going to kind of go through some of the policies. So more or less just following the syllabus. And if I ever start, I was going to start talking and assume that you were seeing what I'm seeing. If you're ever not seeing something that it seems like, hey, he's talking as if we're seeing something, please just let me know. I just probably shared the wrong thing. Okay, so yeah, here's my contact info. All this stuff is up in Canvas as well. So if for now, the best way to catch me is email. When we're back on campus, my office is 4223 on the main floor for the math department. And my office hours for the semester are going to be on Mondays from 10 to 11, Thursdays from 2 to 3 p.m. Those I'll be in my office and on Zoom at the same time. For the first 2 weeks, I am not allowed to have office hours, so they'll be just online. So for the first 2 weeks, here's the link. And this is also posted up in Canvas. So if you've got some questions, feel free to drop by there. I'll be logged on. And if those times don't work for you and you want to meet at some other time, totally happy. Just let me know and we can arrange some other time to meet. Okay, any questions so far? Class going well? Okay, good. Haven't lost you yet. Okay, and so for the grading scheme for the semester, we're gonna have 2 exams, each worth 25% of the grade. There's homeworks that are gonna be due roughly each week, though you don't have one due next week. Again, the first one is due in a couple of weeks, and there'll be a final project as well. And that final project is gonna be a group project. And we'll mostly get into that maybe like halfway through the semester. We'll start getting into the details of that. But the gist of it is you'll have to, put together a presentation, kind of picking a data set that is of interest to you, and will be, for anyone that's familiar, you'll be presenting at the data to policy seminar that they have at the end of the semester. So the dates for our due dates are kind of dependent on when the symposium, that's what they call it, when the symposium is going to be. I have a good idea of when that is. They haven't finalized it just yet. So I've put it in based on what they told me it is likely to be. But I don't think we need to worry about the project too much at the moment, but just keep that on the radar, that is something that's going to pick up and be a bigger part of the class like midway through and towards the end of the semester. And so as far as the homeworks go, I suspect almost all of them are going to be done in our Markdown, which we'll get into today. So you'll be submitting your stuff electronically in Canvas is how I'll collect them. Any questions about that? Okay. Then the plan for this semester is our first exam is scheduled for Tuesday, March 15th. So that'll be kind of just before spring break. And here's the plan for what's going to be on that exam. So I'll kind of talk about the textbook in a second, but that's kind of referring to some of the chapters that we'll be covering from the text. And then the second part of the semester, and the second exam is going to be during finals week. So that will be, depending on when Auraria schedules things, it'll either be the Tuesday or the Thursday of finals week. So your final project will be done by that point, and you'll just have that last exam for finals week. And all of this stuff is up in Canvas and on our syllabus too, just for your reference. All right. Okay. What is this? I see. That's what I don't want. Okay. Yeah, so the textbook is over here. So it's by Faraway. We're using the second edition. You know, I don't know what the cost is. I think it's about $70 maybe last I checked. But it's a super nice book. And there's a lot of nice resources in R that we can use. So I think it will help us a lot with terms of like really nice data sets to work with. We'll be doing some stuff with R initially for like the first week or two using our own notes. So you won't need the textbook for a week or two. So if you want to order it now and it takes a week to get here, that's not going to be that big of a deal. And then in addition to this, we have a second supplemental text that's on the syllabus that is available through the library. So you can download PDFs of that from the library. So I wouldn't recommend buying that unless you really like the textbook. It's available in e format in the library. So any questions about the text? I'm trying to keep up with the chat as well. I don't think there's anything there, but if something's in the chat and I don't see it or I don't respond to it, I might have just missed it. So feel free to just raise your hand or someone let me know. Yeah, okay. So as far as the guidelines go for the first couple of classes that we have here, it's great if you can keep your camera on. It helps me psychologically when I can see your faces, then I know you really exist. That's great. If you have a nickname or you want to put your preferred pronouns up there, that certainly is a good idea as well. And everybody here is muted, so that's great. So let's just kind of be aware when you're muted and unmuted and so on. Yeah, and so if something happens in these classes where we're all together, if you crash, just kind of log out, log back in, that usually fixes it, but don't freak out. I'm recording things, so whatever you happen to miss while you're logged out will be posted up on Canvas. It has happened that it's crashed on me. That's a little bit bigger of a problem. Please don't go anywhere. Just sit in the room and I will come back in as soon as I can. And if for some reason, like my internet has totally collapsed, then I will send an email out to everybody like through my phone or something like that. We've never hit like DEFCON 1 like that with Zoom yet, but we've been like at DEFCON 3 before. So if I kind of disappear or if I'm frozen, just give me a few minutes and I'll be back in. I think that's really all I wanted to say about this. Yeah, and so I just want to kind of close the kind of general gist of things just by saying, like my main goal here is to just make this all a really nice experience for you, make you all succeed. And that might mean different things for different people. So if there's anything at all that I can be doing to help you, for those that have had me, please, just ask me, and I'm going to do whatever I can to help you, as long as you're willing to help yourself as well. So as long as you're willing to put in some work, I think we'll all be fine in the class. So I think the most important thing is just don't be afraid to ask for help, whether that's with your classmates, whether that's with me. Definitely encourage you to be working with each other as well. And so, you've all done the prereq, you're all in here, you're all able to do well. We just all might be starting at different points. So I'm not that concerned necessarily where you're at today, but where you're at tomorrow, is that like a little bit better than where you were today? If that's the case, then we'll all be moving in the right direction. So it's not a race. I've had plenty of students that, have a little bit of struggle at the start and then like turn around and do some really impressive stuff. So if you're having a little bit of trouble initially, I think what that means is it's really important for us just to get on the same page, because as you've been in some math classes, you know that it can get more difficult to catch up the longer you let things go. And the kind of the more you hunker down in the first couple of weeks, that kind of foundation goes a long way for this semester. So just kind of keep that in mind. So if you are a little bit worried initially, that's normal. I mean, it's normal to feel that way. And if there's something that I can be doing to help you get acclimated in the class, just let me know. Yeah, and so, yeah, I don't expect everybody to do perfect work all semester long. I promise you that I will make some mistakes during the semester myself. My answer keys might not be perfect all the time. So what's most important is not getting the right answer all of the time, but kind of just knowing what to do when you get something wrong, right? And that is like, don't just disregard it. Try and figure out why it was wrong. Try and figure out if you've got some misunderstanding. And if you're totally stuck, that's when it's helpful to talk to your classmates or talk with me. Okay, are there any questions about the kind of overview of the class? Let me then just take a look at the syllabus and let me know if there's anything on here that you want to talk about. So we do have a location. It was in King something or other, and then I complained. So now we're back in the math department. So yeah, so this is actually, I saw that was changed on the schedule. So we'll be in 4125, which is nice. My office is just across the hall. So I will update that on the syllabus, but that is for sure. And yeah, so you've got all the information here. Yeah, and so then hopefully you read a little bit about RStudio or R. If you have no idea what that means, that's okay. We'll make sure by the end of today you do know what that means. Yeah, and the schedule and everything is back here. Exam dates, just so you know, like all the information about the homework, final project, kind of why are we doing these things, I think is important to keep in mind as well. Yeah, definitely look through the course policies, you know, and if there's anything at all that I can be doing to help you, please just let me know. And there's some section about some resources as well for support, whether it's academic or otherwise, at the end of the syllabus as well. It's a long document, but yeah, there's you know, hopefully if you have any questions about the class, you've got some information there to help you out. But if you don't find it in the syllabus, please just let me know. Okay, how's everybody? Okay, so if there aren't any questions about the kind of overview of the class, then we can get started. So I'm going to open up that file, which was the notes 1 in R. I think I've got that. And I'm going to just share my R screen with all of you. So let me first open up a poll here. Actually, this would be good to get some information. Man, I feel like it's been so long since I've used Zoom. Polls, here we go. Okay, I was so good at this. Okay, so I just want to ask 3 questions here. Hopefully you can see the poll. Just trying to gauge like how much experience you may or may not have with R, RStudio, and R Markdown. And you know, this is all anonymous, so there's no need to mislead me as far as how you all what your experience is with R and RStudio. Right, that was very efficient polling right there. Everybody's done. So let me share these results with you. I think you can you see the results? Yeah, okay. Yeah, okay. So okay, so out of all 20 of us, everybody has used it at least a little bit. So I'm guessing that you've all have it installed. And as far as our Markdown, a little bit less, okay. And as far as LaTeX goes, even less. Okay, that's good. So I think those most importantly would be our Markdown. Not as important to come. I think it follows pretty nicely if you're familiar with our Markdowns. Not too much trickier. And then LaTeX is just kind of nice way of typesetting math equations. So we'll see that a little bit, but that's not all that essential either. Good. Okay, so if you've got R installed and RStudio installed, then go ahead and open up that file, which is called o1rfoundation.rmd. So that is actually a Markdown file. And I'll open it and share my screen over here. And this is probably really small. Let me know when I've got a good font size. Bigger, is that good?
Yeah, looks good.
Okay. Yeah, so here is the file, and this has an extension .rmd. So by default, when you open this in RStudio, it's going to know how to kind of read in the various formatting for the text and for the R codes. Just to kind of quickly scroll through it, there's kind of two aspects to this document, and one is just like typing up word processor type of stuff. You can see the formatting. We enter things as like unformatted text with tags that will do the formatting for you when you render this to an HTML file or a PDF. So there's a lot of text in here. And once we get into the R commands, there are little blocks where we can add R code to the document as well. So these Markdown files contain both R scripts and just kind of text, a narrative that you can write up. And this is why it's really nice when you're working on your homework. There are some things that you want to explain, interpret, and then there are other things that you want to compute. And so you can do them all in one document. And so the kind of first thing that you might want to do, and this doesn't require any previous kind of exposure to R Markdown, is if you do want to generate your own HTML or PDF file, there's this little knit button up here, and you can choose what sort of output, we call this rendering, what sort of output you want to render this to, whether it's HTML, PDF, or Word. And I'll say the most universal file type is actually HTML. So I'm going to, when I write up Markdown files, I'm going to kind of assume that you are rendering them to HTML. You certainly could knit to PDF as well if you prefer. Sometimes if the PDF knitting doesn't work, you can knit to HTML and then print that to a PDF or something like that. But let me just say, if you don't have LaTeX installed locally on your computer and I have LaTeX in the file, then you're going to get errors if you try and knit to PDF. And so if you see some errors about that, just knit to HTML, and that should avoid those errors. So when you knit to HTML, I just did it, then you get something that looks like this document over here. And so you can see it kind of will format the text that we saw kind of as unformatted with some tags. And it also typesets the R code and the output of the R code nicely as well. So any general questions so far? Okay, then I will stick with using the R Markdown file. And so this way, these are interactive. So I think what's nice from kind of your side of things is you can type your own notes into this section as you like. If you want to put some notes in here, type away. But yeah, so I think based on the response, I think everybody is familiar a little bit with what R can do. So I mean, R is one of the top two programming languages for data science, this and Python. And I have found myself in the position of teaching one class in Python and one class in R this semester. And I really hope I don't mess up my indexing. So I will do my best to really stay in R over here. And so there's kind of, if you're looking at the screen, there's four components to this screen. And so on the bottom down here is what's called the console. And so this is like kind of like your calculator. And so consoles are good if you want to just like execute one line of code, like what is 1 + 1? Okay, that'll do like really simple one-line calculations. Oftentimes, right, we're going to be writing things that have if statements in there and, involve various lines of code. And when that's the case, that's when an R script might be more useful. I have a file just to kind of see what that might look like. Here was a file. I was doing something in 3382 with the central limit theorem. So this would be like an example of a script. And notice that the extension on this file is .r. So this means that R is going to read this entire thing as a script, and it knows not to read anything as text at all. So this would just be a place if you want to, like a good sandbox for testing out long blocks of code. We'll talk about commenting and other things, but what you can see in this document is there are some lines that start with pound symbol, hashtag, and these are what we would call commented text. So anything that appears to the right of a hashtag is read as a comment, and that means that R ignores that line completely. It's not going to do anything with that. It's more just like a prompt for somebody who's reading the screen. So these are really nice ways of sharing code with other people, because someone who gets your code might not know exactly what different parts of your code are doing. I run into that problem when I open up a script that I was working on from a year ago. Sometimes I don't even remember how my own thing works. So it's really nice to just put these little comments in here, just so you know what different parts of the code are doing. Okay, so when you're working up in this screen up top, this is where you'll be typically working with either an R script file or an R Markdown file. And then in this section over here is kind of like your environment section, where you can kind of take a look and see what data sets are open, what objects have, what's been assigned to what object, and so on. And then this section over here, you can either use for your files. If you've generated some plots, you'll see the plots over here, and you can get some help documentation over here as well. So typically, an RStudio window has these 4 different components, though, if you don't have any script open, you might just see the entire console at first. And if anybody wants to like resize things, you can drag things around and resize them as you see fit. Okay, so I will skip over this part about how to install things, but please let me know if you are having any issues installing R in RStudio. So first you install R, then you install RStudio, and then you don't need to install anything for the rest of the semester. Okay, yeah, so we've talked about the layout. And yeah, I don't know, there's like 8 different ways that you can do any one thing in R, right? So I'm not going to necessarily tell you every time, like if you want to run a script, here's one way you can do it, here's another way you can do it, here's another way you can do it. Just know there are lots of different ways to do the same action in R. I might list them the first time, and then whether you prefer keyboard shortcuts or using your mouse or whatever the case might be, you'll kind of generate your own feel for interacting with R. But it's got all the usual things, so opening, saving files, and so on. Yeah, so let me kind of come over into a script. So when you want to run code in a script, I think the most common way to do it is just like highlight the portion of the code that you want to run and then hit run over here. And there are keyboard shortcuts that you can do to like run everything up to where my mouse is, run everything from my mouse to the end, and so on. But when you're in the script, typically you're running different parts of the script together, and you would just hit run. If you're working from the console, then you would just type whatever you have down here and just hit enter, and it's going to run it from the console. Okay, so let's just say we're working from, let's open up a new R script. So let's kind of all start with the same file. So if I want to open up a new R script, I'm going to come up here and just go to the, open a new file over here. And I'm going to open a new R script. And if you wanted to do a Markdown file, you could choose Markdown file over here. Okay, so right, so here, if I hit 1+1 and I hit enter, it doesn't work like it does in the console, right? Enter here means like new line. So again, just remember, if you do want to run stuff, I could just highlight it and run it. And the difference is now, right, the output doesn't appear in my script, but it appears way down at the bottom in the console. And if instead I do something like this, remember, these symbols, these hashtag symbols here are going to mean that this is a comment. So when R reads this line, it's not going to do anything because there's nothing to execute. It just says there was a comment over there. So just a couple of things, and that is if I want to kind of store output data frame, whatever, to an object, in R, we use this symbol over here, as opposed to an equal sign, which you may use in Python. So when we're assigning something to an object, we're going to use this symbol over here. And just keep in mind that when you do something like this and run, it looks like nothing has really happened over here. Right, we don't see 2 anywhere. If I had a more complicated calculation, we can probably do this one without R. Right, you actually don't see what the calculation is, but it has been done and it's just been stored in X. So keep in mind that if you want to do the calculation and see the result of the calculation, then you need to tell R to print that output to the screen. So if I do something like this and run both of these lines, now it does the calculation and it will print it out to the screen. So by default, it's not going to print what X is unless I tell R to print X to the screen. Okay, any questions at this point? So it's a little tricky since I know that we're kind of all coming in with slightly different background in R. So for some, this may be slow, and for others, this may be fast. And so this is where it's lovely to do this over Zoom. It's hard to tell, but if you want me to slow down, just let me know. Otherwise, I'll keep on flying at the pace we're at. Okay, so for packages, the command to install packages is install packages, right? So R is super nice in that if you're not sure how to do something, it tries to be as intuitive as it can be. So packages are just like big libraries where people have written code for certain functions that are useful. So you don't have to rewrite all of little code that people have done. And there's also lots of data sets out there that we can import into R. So as far as the main packages that you would want to have for this class, I'll just type it down here. You only need to do this once, install the package. And then we can talk about how you need to load them. So the main one is for our textbook is Faraway. So there's going to be a lot of data sets that we use, similar to what happened in statistical theory, right? A lot of examples in the book are going to be based on data sets that we're going to want to interact with in R. So the way to get all of those data sets would be to install Faraway. And here is another really useful package with data analysis, dplyr. Tidyverse is another really nice package to have. And ggplot2 is also a nice one to have. So if you've already installed these, then you don't need to do it again. If you haven't installed any of these, I think it might be nice to just install them all now and be done with it. And this should be everything that you need for the semester. when you install these packages, you may get some error messages and so on. For the most part, you can probably disregard all of them and just hope that everything works out okay. Because sometimes they'll have like filter is a defined thing in one package, and filter is also defined in another package, and there might be some conflicts that usually don't really affect our code anyway. So once you've installed these, you're good to go. You may want to update them from time to time. I'm not going to run this because I've already installed all of these. So there's installing the package. That's going to kind of save all of these things onto your local computer. But every time you open up R, if you actually want to use that package, you need to check it out. You need to load the library. So the way that you check it out is using the library command. So I'm going to just load up our text data set. And so when you're using the library command, you don't put the double quotes around the package name. And that's it. So if you want to kind of check to make sure that this library loaded up correctly, one thing that we can do is kind of use this data command to see like, okay, well, what data is in the package, which is, I think I need quotes here, which is Fairway. And if you're, after running that line, if you're looking at something like this, then that means you've got Fairway installed correctly. So these are just all of the data sets that are in this package. So these are some of the various data sets that are used in the textbook. We'll use some of them shortly. So that's going to be the most important one for sure. And these other ones that I had, like ggplot2, that's not required for anyone that is not familiar with ggplot. It's just another way of generating nice graphics in R. But I'll just say when it's possible to do something in the base R system, I'm going to use base R because that avoids any confusion with different packages and so on. So ggplot is super nice for anyone that's familiar with it. We're going to be using, for the most part, the base package for R when doing graphics. But you're welcome to use it if you like. Okay, questions? Okay, so hopefully you've installed the package and loaded it up at this point. So there's so much stuff in R that like what's most important about R is to know like, where do I go when I don't know how to do something in R? And so step one is like, plug it into your favorite search engine and say, how do I do such and such in R? And I promise you that this is a really large world, and there's someone out there that has had that same exact question as you at some point. And we're a really nice community. Someone has probably posted the answer to that as well out there. So this is a really widely used software. So there's tons of help available online. But if you ever have a question about like, what is this function doing in R? For example, LM is like a linear model function in R. I don't know how this thing works. Just put question mark followed by whatever the function name is. So in this case, LM. And out comes, okay, this is a function that we use to fit linear models. Here's how it works. Here are all the options that you can enter into it. And oftentimes they'll have some examples at the end as well to show you how it's used. So these are super nice, right? It's probably more documentation than you need about this. So keep that in mind. There are other things that are like topics, like Hey, but what goes on with logarithms in the R system, hitting like a double question mark, it's going to just search through all of its base packages to see like, oh, where does something related to log come up? And then you have a couple of options to click on this, and I can see, okay, is log base 10 or is log base E? And you can see the documentation on that. So I think if there's one thing to take away today, it's how to get help in R, okay, which is a question mark, makes sense. Okay, so for our Markdown, right, this is the file that we're working with right here. There's super nice built-in help. Oh, there's chats coming in. Okay, is there anything I missed? You guys are welcome to chat as much as you like to each other. Sorry, it's hard for me to talk and look at my screen and read the chat at the same time.
Yeah, I was just trying to knit the file that you were knitting, and it wasn't doing so because it's missing a picture.
I see. Okay, yeah, so thank you. If you had that error, here's where that picture is. That's right. Good question. So this this image is on my local computer, right? And this file doesn't probably exist in the same place on your computer. So you can either just delete it. You don't need this here. So I would say just delete that line and then knit it. Sorry, and then that should work. You can also comment it out like this. So if you know any HTML, really it's HTML that's generating the text here. So this kind of is like the HTML equivalent of the hashtag, right? This comments out that thing, so it's going to ignore it. But it's probably just easier for you to delete it. Sorry. Yeah, you probably all might have had a similar problem. Thank you. Let's see. What? Sorry that I missed that in the chat. Is there anything else okay, awesome. Yes, delete line 57. Perfect. Good. You answered the question as well. Thank you, Patrick. Okay. Yeah, so we are down here, right, in the R Markdown section. So typing R code is going to pretty much be the same in R Markdown as if it would be in an R script. The tricky part is getting like all of the formatted text to look clean when you render the file to HTML. And if you go way up to like the help menu at the top of the screen, which you probably can't see because I'm not sharing that part of my screen, but if you go to the help menu, you'll see in that help menu, there's something that's called Markdown Quick Reference. And if you click on that Markdown Quick Reference, then you get all of this Markdown Quick Reference stuff over here. And to me, like most of the most common things that you would want to, formatting that you would want to do, they explain how to do it here. If you want to put something in italics, bold, you want headers, lists, and so on. So I think pretty much anything you'd want to know how to do in R Markdown is in this quick reference over here.
What header was that under?
If you go into the help menu way at the top,
Got it. Okay.
then there's Markdown quick reference. There's lots of other stuff here. I think another nice thing is the keyboard shortcuts help as well. That'll just, I don't think you can actually see that. I don't know how Zoom screenshots things, but if you do like the keyboard shortcut, then if you like working with shortcuts, it'll show you like, here's how you can do anything without your mouse and use a keyboard shortcut instead. So you can see like I've used that formatting over here. So these are setting up different levels of headers. The more hashtags you put, the lower the level becomes. We can put ordered lists with numbers. We can put unordered lists, bulleted lists with these asterisks, or you can use dashes as well. Yeah, so, if you want to add a bullet, you just, go ahead and type away. And so for anyone that's kind of worked in Python, these are kind of similar to like Jupyter notebooks as well, where you can add some text and you can add some code to them. Okay, so when you're working on your homework, right, you'll be kind of, some things you'll be typing in answers. You won't necessarily have to write code to answer them. And then some things you'll want to write a little script to calculate, to do some operation in R. So the way that you start in R block is you type these 3 apostrophes followed by an R in curly braces. So I'll just kind of start it over here. And you want to be sure that you pick the apostrophe that's kind of pointing down and to the right. And then you start it like this. So that's going to kind of start your R block of code. And then you end it by putting the same 3 apostrophes at the end. And those blocks appear in little grayed out areas on your screen. At least that's how I've formatted my R Markdown. So whatever I type in between these lines is going to be read as if it were typed in an R script. So I could do something like X is equal to the square root of 2. Right? And remember, if I just do this and so now when I want to run, when I want to execute the script over here, I don't need to render the entire file. Okay, usually that's not what you want to do. I just want to run this little script over here. So I could just hit the play button over here, and that's going to run that script in the console down below. Right, and so here I calculated the square root of 2 and I stored it in X, but I actually can't see what the square root of 2 is, right? Because I didn't print that output to the screen. So if you actually want to see the output, now I can see approximately what the square root of 2 is. And whatever you run in a previous R block is going to be read into the next block of code that you write. So if I want to use the square root of 2 over here, right, I can now use X in my next block of code, and it knows that X, right? I can see X over here. I'm trying to, if you can see like my little R environment over here, I guess I can't highlight it. Right? You can see that it created this thing called X over here. I'm about to do something with Y. I guess I was doing some other stuff in R. Apparently I've used Y for some other thing before, but once I reassign it over here, it's going to get rid of whatever R was before, and now R is going to be X squared, which if I'm doing my calculation correctly, that should give me back 2. And that's what I can see over here. So that's how we can add blocks of bigger blocks of R code. Any questions? There are also what you might call like inline R commands that you might want to do. So sometimes I might want to like put X over here. So if I put an inline R code like this, what it's actually going to do is when what's going to appear when I render this document in this part of the document, if I had this in here. How do you think our Markdown is going to read this little part here?
Whatever X, we said X equals, right?
That's right.
Number.
Yeah, so that would, in this case, it was like 1.41, whatever, the square root of 2. That's right. So this is where inline code is useful. I'm saying not so much for like doing calculations, but if you want to refer to a calculation that was done in a previous block of R code, and you just want to kind of put it in line with some other text, then that's possible to do with inline R commands, inline R code. Okay, so that's a quick rundown for our Markdown. Any questions about that? And I think, you know, when you're working with these, I think what's usually more common is you're just playing around with little blocks of code at a time and playing individual blocks and making sure everything is working. And then like when you're done with your final assignment, that's when you would knit the entire thing to like an HTML or something like that. Okay. So next, I just want to mention something about LaTeX. So LaTeX, so this is, you might think it's latex, but in math, we call this either LaTeX or LaTeX, or is how we pronounce that. And yeah, the capitalization of it is what it is. That's how it's written out. And so this is like a really commonly used typesetting system for math expressions and equations. So what you can see is, well, you can see both of them. So when I want to enter LaTeX code, I would begin it with a $. And then whatever I type between these two $signs is going to be read as LaTeX code. You can see what I had to type on the screen, and then you can see what actually is going to be rendered when I create this to an HTML. So here's like the exponential distribution that I've typed in over here. And so for those that have like entered math formulas using a word process, using Microsoft Word, they have like an equation editor. So LaTeX is pretty similar to like the types of things you can get with an equation editor. It's just the more you work with it, the more you hate the equation editors and the more you really appreciate LaTeX, because you can really customize things really easily beyond like the level of customizing that you can do with Word. And you can do it all by typing as opposed to like going up and playing around with like clicking on things and using dialog boxes and things like that. So this is really heavily used in the STEM world, in the math statistics world, when you're publishing things. Like typically these are written up in LaTeX documents. So you definitely don't need to get all that much experience in LaTeX this semester. I would encourage you to go for it because it is super helpful. So I'm going to just include some of that information over here. There are situations where you've got really complicated formula, such as this one over here is the Gaussian. And this is not being displayed for some reason. But you can see it hopefully on the rendered document what it looks like. So, you know, if I want a Greek letter mu, I just type \mu. So pretty much how LaTeX works is if you want a symbol, a math symbol, you pretty much hit the / symbol and then what you think that symbol might be called. So mu is mu, theta is theta, sigma is sigma, pi is pi, and so on. So it works pretty intuitively. But I put a link down here that gets into more of the details about how you might want to typeset different things in using LaTeX. It's a really nice way of making math reports look really nice. So if you have any questions about that, happy to help as well. There's like a huge number of people out there that use it. So if you're ever like, I don't know how to get a little black box that has a little widgety thing on top of it, you can Google that and someone has figured out how to do it. Okay, any questions? Yes. Sorry, I'm like a bit delayed on the chat here. Good, nice answer, Derek. Thanks for that. Okay, so I think that's kind of the main gist of like navigating our RStudio, our Markdown in about a half hour's worth of time. Definitely the more experience you get with these is just a learning process. You're bound to get lots of errors when you're working with R, and at some point you start to pick up on like, oh, I've seen that error message before. Here's how I can fix that problem. But we'll all help each other out. Okay, so just want to talk about kind of data types, data structures, maybe before we call it a day today. But we're going to be working with data sets this semester, and some of those data sets are going to have quantitative variables, some of them are going to be qualitative variables, and the type of analysis that we can do is going to depend on what type of variables we're working with. So there are 6 types of data types in R. You can see them all listed out here. And if you've worked in other computer languages, programming languages, things might work a little differently. So for example, R by default reads numbers as decimals, whereas Python, if you type an integer, it's going to read it as an integer. So if I type the number 1, it's going to read it as 1.000 going on forever. If you don't want something to be a decimal for whatever reason, then you put an L at the end of it. So 1L would be read as the integer 1, as opposed to 1.0 repeating forever. So I would say less common is going to be us working with integers, but usually when we're working with quantitative variables, we're going to be working with decimals, so we'll be dealing with decimal numbers. And then we have logical Boolean values, which are true and false. There is a complex number data type. I don't know how much will come into that, and a raw data type, which I also don't know how often we'll run across that. This is kind of just like a miscellaneous type of data type. So if you're ever unsure, I'm working with some object in R, and I'm not sure whether this object is an integer versus a decimal or a character or whatever the case might be, then the function for that would be type of. So we can run this code, for example, and you can see that hopefully you're getting similar output over here, that it by default reads 1 as the integer, as the decimal 1.0 forever, whereas this is going to be read not as the string of characters 1L, but as the integer 1. Okay, any questions? Okay, so yeah, as far as kind of the big breakdown goes, right, we're going to be working with categorical variables, qualitative variables, and for the quantitative variables, the numeric variables, right, these could be integers or they could be decimals. But both of those things would fall under the numeric kind of sub-classification as opposed to being a character. And this is something that you definitely want to be concerned about with like a lot of the data sets that are pre-loaded in the Faraway package. All of the data is like formatted perfectly to how you might want to use it initially. Whereas you'll see when we're working on problems where you're out there finding your own data sets, that's not going to be the case in reality. And so just because something looks like a number, we'll see there's going to be times where that number actually is being read as a character, and that means we can't do mathematics on adding characters together is different than adding numbers together. So just be careful that what you see on the screen may not be what is actually stored in the data, and that's where figuring out what type of variable you have is useful. Yeah, okay, so other things that could go wrong with your data in terms of like having it be the wrong sort of data type that you might have expected would be a lot of times data is missing some values in certain spots, right? So people don't fill out all of the answers on all of the questions on a survey, and now you're trying to make sense out of responses on a survey, and we don't have responses from everybody. So in R, missing values are stored as NA. And this is not the text string NA, it's an, you can think about it as a value itself. So NA is like a value, and that value means that there is something that should be here that is not here. And it's useful to code those as NA as opposed to anything else, because R has a lot of functions built in that can handle NAs. Whereas if you instead say, like, I'm going to enter the characters missing for any missing value, that's going to, R is not as hardwired to treat the characters missing as representing a missing variable, whereas it knows that NA means there's a missing variable value. And so there'll be cases like on your very first homework assignment where you've got a data set that has some missing values, and what are we going to do to make sense out of that data set? Okay, and so I think I'll kind of stop today just talking about the data structures, and then we can kind of get into different ways of indexing and creating vectors next time. But for data structures, there are 5 data structures, and the first 3 are really all the same. So there are vectors, matrices, and arrays. So a vector is a one-dimensional array. A matrix would be a 2-dimensional array. Otherwise, arrays can be 3, 4, 5, 6, 7, n-dimensional, right? So arrays can have any number of dimensions, just like our minds usually handle rows and columns, and we stop at 2 dimensions. But you could, in theory, have higher dimensional arrays. And so these 3 data structures are all what we would call homogeneous data structures, in that, right, a vector is made up of several values or characters or whatever. All of the data types in a vector, matrix, and array have to be the same. So I can't have a vector that has some integers and some strings in it. Everything in a vector has to be the same data type. Everything in a matrix has to be the same data type. The last 2, data frames and lists, these are heterogeneous data structures, meaning I can have a list where some things are integers, some things are strings, some things are raw data, and so on. So a list is like a one-dimensional thing. It's a vector, but all of the items in the vector could be different character types or data types. And the most common thing that we'll be working with this semester is a data frame. So a data frame is an array which can involve different data types. So maybe one variable is strings, one variable is decimals, one variable is integers, and so on. So yes, there'll be times in the semester where we're going to want things to be data frames. There'll be times where we're going to want to extract some of that off and just work with vectors and so on. So just be mindful of these things. Yeah, I mean, vectors, matrices, and arrays, they're all kind of used interchangeably. It's just how many dimensions they have. Okay, so I think I will stop here. Sorry that I did a lot of talking today. This is not normally how I like to roll with things, but I just want to make sure that we're kind of all getting up to speed with our that's good. It seems like for most of you, you've got at least, it's not the first time you're looking at R, so that's good. But any questions about anything before we break for today? Okay, so if you do have any questions, you're welcome to shoot me an email. We'll meet at the same place here again on Thursday using the same link. And I've got office hours. My next office hours are Thursday after class, but if anybody wants to chat before then, just let me know. Otherwise, yeah, nice to see you all. Hope you are all comfortable. Business up top and pajamas on the bottom. So that's kind of like the benefit of being at home, I guess, for a couple more weeks. And yeah, I'm looking forward to seeing you all on campus in a couple of weeks. But otherwise, have a nice afternoon, and I'll see you all on Thursday.
Thank you.
Yep.
Thanks,
Have a
Adam.
nice day.
Yep. Take care.
Thanks, Adam. See you later.
See ya.